Okay, so today we are working with lab number 7. And in this lecture, we are going to work with the scenario in which you have different arrivals patterns throughout the day. So far, we've been assuming that the arrival pattern will not change, or it's not like it's not going to change. That the arrival pattern is going to follow the same probability distribution for the entire day. And we know that most systems, that's not going to be the case. You're going to have times of the day in which you're going to have very high volume of entities going through your system. But there might be other times of the day in which that volume is going to be different. And assuming that the same pattern is going to be valid for the entire day might not be the best assumption for some systems. Especially when you're dealing with service systems like hospitals and airports and restaurants, schools, universities, parking spaces. You know that demand might change, not only during the day, but also depending on the day of the week that you're studying. So today we are going to start looking at how can we set up these different arrival patterns for our system? And then what are the assumptions that we're making in terms of the modeling tool that we're going to use? And then we're going to implement that strategy in using one example. So that's the idea for today. On lab 8, we're going to take the same ideas and we're going to apply it to the availability of resources. So again, thinking about, well, if you experience higher volumes of entities going into your system, let's say you're looking at the airport facility, you know that more passengers means that you might need more security lanes open. So how do you use also these schedules to set up your resources during the day and change the capacity according to the needs? Well, that will be on the next lab. So today we're going to just look at the arrival patterns. I also built the statistics that are going to be collected today. We're going to be looking at the working process one more time. I need to clarify that. So we are going to be collecting WIP working process because there's certain occasions in which you're going to just use the output, and there are certain occasions that you want to deal with the time persistent statistic. So we need to make sure that we are looking at that and knowing when one of them will apply and when the other one will apply. So today we're gonna spend some time also looking at how to compute the working process using two different scenarios. So that being said, always remember that you need to, I think I'm using the wrong screen. Let's see, duplicate. So always remember to save your model once you get started. We've been going through this throughout the semester. So again, we're going to stay with Arena for the rest of the semester. This is going to be, I think, easier for your project. Make sure that you're using the same tool that you've been using throughout the semester to work on your project. And we talked about resource sets last time. So hopefully there's no questions about that. And then the schedules. Okay, so this is what's new for today. This is gonna be under the basic process. There's a module that is called schedules, and it's one of those modules that has like a spreadsheet-like format, or in terms of the icon that's being used. And this allows you to define an arrival rate based on daily time or a calendar. And then once you have set up that arrival pattern, you can fix that or enter that arrival pattern in terms of the schedule in your create block. And then based on that, the entities will arrive according to that schedule. As I mentioned already, there's also, you can use schedules for defining resource availability. And that's what we're going to be looking at next time. So that's why I have these two bullet points. So the first one is the one that we are going to be working with today. So what are the parameters that we need for the schedules? They're listed here. So first of all, we need to specify the name for the schedule. This is what's going to help us identify the schedule that you're going to be using. This is very important, especially when you're dealing with different create blocks. So you might have, let's say, looking at the airport, you might need different type of create blocks according to, let's say, you're looking at different doors of the airport. So having a different name for each one of those schedules allows you to identify the one that you need to apply to the create block. And in terms of the type, you need to specify a duration. So that means that how often, I mean, in terms of the time periods that you're going to be using for collecting data or inputting data into your schedule. So this could be every 10 minutes, every 30 minutes, every hour. So depending on the changes that you observe in your system, you might determine that it's better for you to specify, let's say, an average rate of arrivals every 15 minutes because they change so quickly. So you need to capture the difference every 15 minutes. But if they don't change as quickly, you might need, 30 minutes is good enough. You see that the patterns might not change as quickly as 15 minutes, but every 30 minutes you see a major difference, or every hour. So again, this is going to be depending on the system that you observe. In terms of, so in our case, we're going to be defining that time duration, and then based on the time duration is the number of time intervals or the average rates that you're going to be collecting in terms of the time intervals that you're going to be observing. So for instance, in your project, if you're observing for an hour and you want to capture the arrival difference in arrival patterns, you might need to look at every 15 minutes to see if there's a change in the rate of arrivals. In your case, since you are observing during the peak time, I not necessarily expect you to have a major difference in the arrival patterns. But if you were observing, let's say, for the first 4 hours of the day, you might see, like at the beginning of the first hour, you might see a high peak because they were serving breakfast maybe, and then a lower volume, and then again going back up for lunchtime. So that's the type of dynamic that we want to capture. We are going to use also the capacity, not the capacity, but the type arrival for our schedule. So this, again, looking at the arrival rates of entities. This, I think I'm going to look into that in a minute. Yes, your question?
Yeah, you just said arrival rates, and whenever we're using the create, we're not using the arrival rate, we're using the enter arrival time.
Yes, that's a good question. And the question is, every time we look into the create block so far, we've been using the time in between or the time between arrivals to define the parameters of our probability distribution. That's correct. The way the schedules work in Arena is that they assume that they follow an independent, identically an independent arrival process. And under that assumption, they assume that which is a good assumption, most of the systems will follow that assumption. They use a Poisson distribution to define the arrival pattern. And that's why we use the arrival rate. Then the system will transform the arrival rate into an exponential distribution per time period.
So for this case, we'd always assume that the arrivals would be follow an exponential.
And we are assuming that we have an identical lead and independent distribution process, which is typically the case. And under that assumption, if that assumption is not correct for your system, then this might not work for your system. This might not give you the arrival pattern that you're following. And there will be other more advanced strategies that you can use. Like, for example, you can use a branch block to change the arrival process during the day. You might look into, let's say, every 2 hours, you will increase or decrease, or you will have these many entities being discarded. They will not go into the system. But you still follow the original distribution that you captured. You're just changing the number of people that will be coming into the system according to the day. But for the purpose of the class, we are going to use the schedule. And we are going to assume that we have an IID process that's going to follow a Poisson process. And under that assumption, we are going to have exponential distributions using that arrival rates for the time periods that we're observing. These are time units. Time units are going to be seconds, minutes, hours, days, as we have seen so far. And we also have a scale factor. This is more into, let's say you're doing experimentation. You are observing your system, following the data that you collected from your system, and then you're inputting that information into your model. But let's say you want to do some type of experimentation with your system and say, okay, what if I increase my arrival process? Let's say I get 10% more passengers or 10% more customers. How is my system going to react to that? We can do that with this scale factor. You're basically multiplying that arrival pattern by, let's say, 1.10. That will give you a 10% increase into your system arrivals. So that's part of the options that are available for you to study your system. So you modify the schedule by a scale factor, and what it's going to do is going to multiply that arrival rate by the scale factor, again, 1.1, 1.25, and according to that scale, the true arrival rate will show up for your system. And the duration, this button that allows for graphical rate editing. I don't know if it's the new version of Arena still allows for the graphical method for the editing. It was available a year ago. And this is what I'm referring to with the arrival graphical editing option, that you can actually build a graph and see how the arrival pattern will change throughout the day. So for example, here we start the beginning of day 1, time 0, until the end of the day 2. And based on that, you can specify, let's say at 12, if you assume that time 0 for you is 12 a.m., you can specify how many or what is the arrival rate for the first hour. Okay, so this part right now, these bars are representing hours. Those hours will have a separate or a individual arrival rate. So in this first column, number 1, the arrival rate is 2 entities per hour. And that pattern is the same for the first 6 hours. Then after the 6th hour, that will jump up to 4 arrivals per hour. So you see that pattern is repeated for 2 hours. And then for the last 16 hours, the arrival rate is 8 entities per hour. And that's how the end of the day is scheduled in this case. So this graphical interface, not sure if I think last year it was there, but I was looking for it today and was not able to find it. But right now what you have, and I like to show both just because I think this is easier for the students to understand. But what you will see now is that table that I have developed here at the bottom of the slide, in which you're going to have 2 columns. One is value and the other one is duration. The value will identify the arrival rate. And the duration is basically saying how many time periods you're gonna have with that arrival rate. So if you were to look at this figure right here, the graph, this table with the value and duration is representing the same information. The arrival rate of 2 in the value column for 6 time periods, which is the duration. And that's what we have here from 1 to 6. After that, we have an arrival rate of 4 for 2 time periods, and that's the duration 2. And then you have an arrival rate of 8 for 16 periods, which is the duration of 60. So in this current version of Arena, again, the interface, the visual interface might not be there. We're gonna be entering the values following that template or table. Yes.
Is this value a deterministic distribution, or are these value that fits into lambda into a different expression?
Yes, so that's a good question. So again, this is going back into the definition of the arrival rate. So if it is a Poisson distribution, which is the case in this tool, we know that for Poisson, always the arrival rate, the inter-arrival times for a Poisson always follow an exponential. So what you will do is value will represent that lambda rate for the Poisson. In order to get the mean inter-arrival time for the exponential, you do 1 over lambda. So basically what the system is gonna be doing is 1 over 2 in the case of the arrival rate equals 2, and it will plug that value into the exponential distribution. Good question. So once that schedule is being defined, we can go to the create block and set up our arrival in terms of a schedule. So you'll go the time between arrivals. Now the type is gonna be a schedule, and then you're gonna find the name of the schedule, which is gonna be given by you. In this case, it's called a schedule. Good. Any questions? And we'll go through the example, and hopefully it will make more sense once we start looking at the model. But that's essentially what we're gonna be doing today. In terms of the statistics, we're gonna revisit that time average statistic, specifically for the working process. So there was some confusion, I guess, for my part. I didn't specify this from the beginning. When you're looking at the working process, we did 2 things in class. One of them was to look at the working process for the entire day. So what is the average working process for the day? And the other thing that we did was the working process for the end of the day or for a specific time of the day. So those 2 are different. When you're looking at the working process for the day, you're trying to measure that change in terms of the working process during the day. And that's typically observed as a time average statistic. But if you're looking for the final value, let's say at the end of the day, the working process at the end of the day, or the working process at a specific time of the day, let's say at 6 o'clock, that is not looking at the changes throughout the day, is looking at the specific observation. So when you're looking at the time average during the day, we had to treat the working process as a time average statistic. When we are looking at a working process for a specific time of the day, we just treat it as a variable, which is just reporting the output for the report. So today we're gonna have 2 data collections from those 2 different perspectives: the time in system for the day and also a time in system for a specific time of the day. Yes, sir.
Is there a schedule for the entities per arrival?
The number of arrivals per you can still That's a good question. You can still specify how many entities will arrive. And that could be based on a probability distribution. If you do it deterministic, like you input a number on the create block, it will generate that number every single time. Yes. So, but within the schedule, there's no way for you to define that. You have to still rely on the create block. Okay, so let's look into the model for today. So this is the example that we are going to code. So essentially what we have is a 24-hour store in which customers are going to arrive following a non-stationary arrival process, meaning that you're going to have different arrival patterns throughout the day. In this example, we have 4 entities per hour for the first 10 hours of the day. Then we have 10 entities per hour from 10 a.m. to 6 p.m. And then finally, 8 entities per hour from 6 p.m. to 12 a.m. So following that arrival pattern, customers will go into the store. That gamma distribution is specifying the time they will spend inside the store. So this is basically a delay. And then after they shop, they'll go into a cashier, single cashier, in which you're gonna pay for your items. And then we have 50-50, two type of customers that will differ in terms of the time they will spend for paying. So customer A or type A will spend 2 minutes, and then customer B will spend 5 minutes to pay. And then the statistics, we're gonna run this for 10 days. I'm sorry, for 10 replications and 10 days per replication. And we are also gonna look into how do you prioritize the shortest time first. Okay, so that's gonna be a new item for the model today. So basically, you're gonna have a line here, and you're gonna specify you wanna put the entities with the shortest time. They wanna go first into the queue. Not saying that's something that will happen in practice, but there will be some scenarios, let's say in industry, in which you might want to prioritize some of your items or shipping, right? So these shipping items should go first because they take less time. So we'll look into that. And then the statistics that we're gonna collect include the mean number of customers in the system. So this is the working process for the day. And then the mean number of customers at 6 p.m., which is a specific observation. And also we're gonna try to compute the average cycle time. Okay, so let's get to work. Let's open Arena.
And was the breakdown going to be 50-50?
Yes. Okay, so we'll save the model. You see do you want me to turn off the lights or we're good?
Okay.
Okay.
Whenever we're doing the random assignment of like A or B, should we use discrete distribution or the continuous?
The discrete distribution? Yes. Yes. Or in this case, you can also split them. using just, you can use, you need an attribute in this case. You need an attribute, yes.
Because I'm assuming that we have to know which one is which.
Yes,
area,
because you're gonna also assign a processing time to each one of the entities. And then use that attribute to do the delay. And also the prioritization. So you need to have an attribute for the processing times. So let's include our templates. So basic process. So I save it, my model. And then let's start by including a create block. We need to assign some attributes here, was we need the arrival time. So we're gonna start with that. We're gonna define attribute arrival time. We need that for the cycle time. So the arrival time, and if you want to specify also the attribute, let's call it customer type. And this could be, because it's 50-50, right? So we can just build an expression here with a discrete probability. And it's actually the same default distribution. So 50% one, and then the other 50% two. So those, oh, and then we also need the working process, right? So it's another thing that we need to capture. So WIP +1. And this one is available. Just remember, working process is available. Okay, so I think we got everything now. And from here, I can do the delay for the shopping time. So let's do, we can use the process or we can use the delay. It's up to you. It's gonna do the same thing. If you use the process, you just have to remember that you're gonna use the process as a delay. So you don't need the cease and the release. In my case, I'll use the delay just to make sure that it's clear that we are going to just delay. And then this is based on a gamma with parameters 5 and 4. So your shopping is done. And then after that, we need to go to cashier, right? So we need to specify the processing times. So for that, I will split the entities. And this is going to be, instead of by chance, it's going to be by condition. And I'm going to use an attribute, customer type. And if the attribute equals 1, that means that's customer 1, right? So I'll send that through the true branch, and then the rest of them will go through the false. So I have a two-way by condition decide block that is going to look at this attribute customer type, check if it is equal to 1. And if that's the case, the entities will go through the true branch, and the rest of them will go through the false. So I need two assign blocks now. So for the first one, I'm going to define an attribute. I'm going to call this one processing time. And for entity 1 or type A, it takes 2 minutes. So this value will be equal to 2. So branch through will go to this assign block, and you are going to assign this attribute processing time. And then I'm going to make sure that I connect this to here so I don't forget. And then I'll go to the other assign block, and I'm going to use the same attribute. Let's go processing time. And this one is 5.
The reason that we're assigning it directly to the entities and not setting it up in like a table like we did last lab.
Last lab, we were doing different processing times for the resources, right? And that one was depending on the actual resource, right? The processing time was based on the resource that was used. In this case, the processing time belongs to the customer, right? So it's like saying you had a customer with a big a cart full of items, and the other one has a cart with few items. One of them will take longer than the other. Yes. So I guess that's the time of a scenario that we are looking at here. Good. So moving forward, we got to do the processing. So we get to the cashier, we only have one. Right, so I'm going to do the delay release, the C delay release. And my resource is cashier. I only need one unit to seize this cashier. And then the delay is going to be based on an expression. This is going to be in minutes. Let's see if it shows up here. No. So the expression is going to be the processing time. So when the entity gets to the resource is going to call that attribute from the entity, and it's going to delay based on that attribute. Okay, so yes, looks similar to what we did last time, but it's different, right? You're still defining in last time we defined it's a expression and also a resource set, and we connected both using this index that we were saving in the process, and then we were calling that expression and then tell the model use the index to get the right distribution. In this case, the information is coming from the actual entity. You don't have to set up the time based on the observations of the system, but they are going to be based on the behavior of the customer in this case. So we got the process, and then there's another thing that we need to specify in this process. Let's see, got the resource, cashier. We go to the queue here. First in, first out. That's right. So that's typically what we use to define the rule for the queue. But if you go to the queue module and you go to that process one queue, you have other type of rules that you can use to manage that queue. There's first in, first out, there's last in, first out, there's the lowest attribute value and the highest attribute value. So for this specific model, we are saying that we're going to give priority to the processes that are lowest, right? So we can select the lowest attribute, and then this is going to ask you, okay, so which is the attribute that you want to use? And here we can find out. We can establish the processing time, or we can, in our case, it will also work if we use the customer type. Because the one with the lowest value for the customer type is also the one with the smallest processing time. But to make sure that that's not confusing, let's just make sure that we say, okay, lowest processing time is gonna go first. Okay, and we're gonna compare the two just to make sure that we notice the difference. So we got here to process. Okay, so the actual model. Yes.
Shared there, what does it mean?
This?
Yeah.
So we can, that's a good question. Let me see. We go here to home. It's share, right? Share or shared?
Shared.
So
If you share by multiple processes.
yeah, the primary purpose of a queue are two types of queues: the arena, individual queues. Entities in this queue may be displayed. The animations the same. When used with resources, they may be shared among modules. That's not very informative. Okay. So I guess if you have something like what we had last time, with you're using only one queue and you're sharing that queue with multiple resources. This is more in terms of the animation. Resources with 2 hours to define the resource position of allow it to animate the resource at each station. Yes. Yeah, so I'm not very well experienced. I mean, I'm not experienced with that option, but I think it has to do with the way your animation is gonna work. In our case, we are not sharing this as a single resource. But I can look into that more specifically, and get back to you on that one. Yes, I never, yeah, so far. So if we click here. Yeah, so in our case, it's not shared. We are not sharing that queue with anybody else. But in our previous example last week, if we were to animate that, we need to make sure that we click here so we get the right response in terms of the animation. Yes. Yes.
Okay, just for verification, we could hypothetically set up the processing times in a set and then call the processing times by using the index, the customer type,
Mm,
because
so that index is used to save the resource that you are seizing from a set, right? So
right,
so in this case, since we only have one resource, we don't have to use that index. So in this example, we only have a single resource in the station, right? Which is the cashier. And it's a single resource. So you use the index for the case in which you have more than one resource.
right,
And you're sharing that queue in that station. So when the entity comes, you don't know which resource you're going to be seizing. You're going to seize the one that is available, right? For the system to know which resource is being seized, you need to save the index of the resource,
right.
right?
What I was asking is the customer type can serve as the index for a set holding the processing times.
Yes, that's true. That could be another way to implement it.
I was just wondering if potentially.
Because you can, instead of using the save index, you can use the customer type as the attribute providing the index of your set.
So it
Yes.
is possible.
It is possible.
Okay.
Yes, it should work. Yes. Good questions. Okay, so any other question? So let's collect the rest of the statistics. So we need to get the attribute, sorry, the working process variable. So we are going to subtract and we also have to collect the cycle time. So this is time. Cycle time. And after that, we can dispose. And then there's another statistic that we need to collect, which is the working process at 6 p.m. But since we're going to be running this for replications of 10 days, we need to make sure that we get the observation at 6 p.m. every day during the 10-day period. So for that, if you don't remember, we can do a separate logic in which we have a create that is going to generate an entity after 18 hours, in this case, 6 p.m., right? 18 hours, 16 hours, 16 hours. And then after that, we are going to record that observation. And then we are going to suppose. So essentially, what we are doing here is to collect the WIP. And I'm sorry, this is not the count.
You said it was 16 hours, Professor?
Yeah, I'll go into that because for the first arrival, we need to make it after 16 hours. And then after the first arrival, we do it every 24 hours. So every 24 hours, you're going to go 16, 16, 16, 16, and so on. So 6 p.m., 6 p.m., 6 p.m. So we'll get into that. I want to make sure that I set up the statistic first. So this is WIP tally, WIP 6 p.m. So we are doing an expression that is going to go get the WIP and is going to put it into this bag, which is a tally. And I'm calling this 6 p.m., WIP 6 p.m. Okay, so the create block. So this is going to be constant every 24 hours. But I want my first creation after 16 hours.
Why 16?
Because we are collecting the WIP at 6 p.m. So we are assuming that our time zero is 12 a.m.
So it's 18 then.
Is 18?
Yeah,
Yes.
that's why I was getting confused.
Yes.
Right.
Sorry about that. Yeah.
That's right.
So I was
That's
adding
great.
for some reason. Yes,
Yeah,
you're right.
5%,
Yes.
18 and-
I say 18 and then went back to 16. Apologize. So it's a Monday. 18, you're right. So 18 is gonna be 6 p.m. and then every 24 hours. Good. So let's check. Let me save this. Yeah, I've done so many things that want to make sure that it's safe. Then check the model. Looks like everything is good. So we need to set up our statistics and then the experiments. So let's go to the statistics.
Statistics or no?
All right.
You going first, the 6 or the output?
So it will depend. Right. So I will show you now. So batch process. Statistics. So first, what we have here is the mean number of customers in the system. So this one is looking at the entire time, right? So for those, we need to use the time persistent because we want to keep track of how that WIP is changing. And we need to provide a name here. So num in system. And remember that you need to use that same number for time persistent statistic to define the output. So this is DAVG num in system. And then I'm gonna call this average number in system. We haven't done the schedule. Building all this thing and the schedule is not, it's not programmed yet. So we have to do the schedule. Yeah, this is a small model, but you can see all the things that are behind it. It's taking some time. So, okay, so we got the statistic for the working process. Now we want to get the 6 p.m. So since the 6 p.m. is just a single observation, we can treat it as a value, right? It's not, we are not interested in the changes. We want to know what's happening at 6 p.m. So we can go and codify this as a WIP at 6 p.m. Let's make sure that what is the variable? Oh, we're using the tally WIP 6 p.m. Right, so this is the TAVG.
Question.
Yes.
So did you have to declare statistic 1 be able to call statistic 2? Or would you have been potentially able to declare the DAVG of the WIP?
You have to declare it as a time persistent just for the system to keep track of the numbers that are changing throughout the day. Yes. If not, then it's just gonna capture the last value. Yes. Good question. So this is average cycle time. I'm sorry, average WIP. Num in system. Num in system at 6 p.m. And then the cycle time. So this is TAVG. Use the right cycle time. Favorite. Check your model. Okay, so the schedule. So you go to basic process, click on schedule. And here we are gonna double click to add a new row. We got to give it a name. You can keep the default one, but it's not very informative. So this is the arrival schedule. So we are going to change this to arrival. And in our case, we are looking at hours, right? So from 12 to 10, from 10 to 6, and from 6 to 12. Right, so these are time units. Scale factor, this is where if you want to increase or decrease the arrival rate. So by default is 0. And the durations. So you click on those and we are going to add 3 rows because in our case, we have 3 different arrival patterns. And as stated earlier, that value is going to use the arrival rate per hour in this case. And then duration is going to be based on the time periods. All right, so in this case, we have the following numbers for 10 hours. So let's put that in here. For 10 hours.
10 for 8.
10 for 8. That's correct. And then 8 for 6. Okay. And I think the model also allow you to define a file name in case you want to generate the arrivals. If you need that information, you can get it from here, like the number of arrivals that you let's see if we can try that. So
This random file,
I'm thinking that's the case. Yes.
we have to drop it in the same directory as the.
Yeah. Let's not.
That's not work.
No, we're gonna because I'm worried it's gonna take more time. So let me just use the
Was 4 for 10.
4 for 10,
10 for 8.
10 for 8 is 8 for 6. So we got that. Okay. What's missing? We got we need to set up things now. So let's go to run, setup, start with the reports. So we're going to do this assignment, then click apply. Go back here, project parameters. This is lab 7. And I'm going to uncheck. And then the replication is for 10 days. I'm sorry, 10 replications for 10 days. And the base time units are minutes. Then apply. We can click or check the batch run because it's going to be long. So, and then try it and see how that goes. Numbers.
I have different numbers.
You got different numbers.
The same.
What do you got?
I got 3.7 for the average WIP.
Yes, that sounds more close than I was expecting. Let's see, what am I missing? What do you got?
I got the same as you.
Same. So this in hours. Let's say the create. Oh,
Oh, yeah.
guess what? We didn't specify the schedule, right? So
Okay, my-
yes. So let's go to create. Set up our schedule. and then select the arrival schedule, and then click OK
Just put it again.
and run it again. Yes. Yes, this is better. You got
I got the same.
same numbers?
I still don't have the same
No?
numbers, but I think that, I clearly did something wrong.
So what I was expecting to see is a higher value for the WIP at 6 p.m. Why is that? Because that's the time period in which you see the largest arrivals in this schedule. So you should expect to see more people inside the system during that time period. So this tells me that this is happening. Cycle time about 25 minutes. I want to show you something else. So you said 3.4 for,
I got a little bit higher numbers across the board, except for the WIP at 6 p.m., which is one. I'm trying to figure out, maybe I sent the second create at a different time.
okay. So I want to show you the animation, right? So let's say I go here. I'm assigning this, but also I'm going to assign something else. You see in the assignment, you had the option to assign a picture, entity picture. So I'm going to click there for this. And I'm at this level, I just want to have very simple animation. We can do a little bit better towards the end of the semester. But what I want to do is to have two things that have different colors. So I'm going to start with this one. So I'll select blue for 2 minutes. And then I'm going to use red for this one. So I'm going to add another entity picture. I'm going to find something red. So there's a red ball here. So what this is doing is I'm assigning you a processing time. I'm also assigning you a new picture. One of them is blue. The other one is red. And I want to see if my rule for the queue is working. So if this is working, then blue should be showing up first in this queue. So I'm gonna try to put this queue here. Should be able to extend this, but it's not letting me. Here we go. So I'm gonna uncheck this box right here because I want to see the animation. So let's see. So it shows up as a report, but then it will change colors. Maybe I need to.
Why is the animation so choppy?
What do you mean, like?
Every once in a while, you'll see.
Yes.
Going into the delay and then relief.
Well, and that's, I will say that's one of the differences between Arena and Simio. Simio separated the logic from the animation. So right now in Arena, you have both. You have animation on top of the actual logic. Simio did it very well. We have a window for the animation in the window for the actual logic. So when you're building the system, you're building the structure, the animation, the actual animation of your system. But the logic is separate, and then you can assign logic to your actual system. Yeah, Arena has that. So when you, for example, like here, I can pull it from the blog and put it somewhere else. But building animation in Arena is a little bit more difficult. So I'm gonna run this faster and see if I can see a queue at some point.
We have like 2 entities per arrival.
Yeah,
So
but
you can
I'll make
actually
it
see-
make it more entities. That's a good idea. Let's try that.
Because it's even just one by one, so.
Yes. So let's put 10. See what's gonna happen.
Immediately starts throwing you error. So.
Might run out of space. Yeah.
That's a good way to go.
Yes. So that's what we want to see, right? That the blues are going first. And that's what's happening, right? So you're giving priority to the blues, right? And if we change that logic, we go back here to the advanced queue. We switch that then to highest attribute. Should be the opposite, right? The red first. Yes. So it's working. That was a good idea. So we can see the actual. So we have a couple of minutes. I can also show you how would you build an animation for a resource. See, I took this queue, it was here on top of process one, I move it outside the model because your entities will go there at some point to wait. But if you wanna like, say a resource or animate a resource, you can come here into animate, click on resource, and this window will show up. There's different libraries. You see here, they're located in your C drive. The library that is open is for people. The animation is not, I mean, it's very old. There's no 3D or anything like that.
This reminds me, did you ever use ProModel?
Yeah, animation is much better there. So you have these other, and this is something that I had talked to them. Like, when are you guys gonna improve animation? And they're not worried about the animation. I don't know. So if you go to equipment, you see more stuff here. If you go and open another library,
It's loaded more.
general, got boxes, things. Yeah, so you can also build your own objects and create a library. Like in that way, you can build things that are more realistic, I'll say. So people, so let's say my cashier here in white is idle. And then in green is busy. And then I can identify my cashier. And then what else? Okay. We can put that person here. And then it's supposed to change colors once I start running it. Let's see. Yeah. So obviously not the best animation of the world, but you can see, at least for validation, verification purposes, you can see that the system is working Um, and then there's also things like graphs that you can integrate. For example, here you can do animation, chart, plot, name.
Plot variables.
Yes, a working process, WIP or working process. The expression, see, WIP. And then you can change the color and it's red. Oh, that's not what I want. Just keep it gray. And then the line color, let's make it red. Mm, Again, if you have more time, you can do better than me, but this is gonna start showing the working process. I didn't specify the values for the YACs, but you can do that. And then you can see how that's changing throughout the day. See, it's going up and down.
It's very interesting that they don't follow a similar pattern.
Yeah, because some of them are going in and out. Yeah. So you get to 10 some point, and goes down. So you're not above 10 at any point so far.
That would probably make sense because the
Yeah.
processing rate.
Good. Yeah, any questions? Just make sure that you save your model. And if there's no questions, then I'll see you on Wednesday. Let me stop the video.